So we're going to go ahead and start chapter 9. And again, this is all going on our third quarter or second semester. So we don't have to worry too much about affecting our semester grades at this point. Our semester grades are pretty much solidified. Hopefully they're good. I'm hoping they are for you. But we're going to go ahead and move on to chapter 9. Remember that chapters 8 and 9 are combined into a test. You guys do have an 8.3 quiz on Friday that does with very similar to what we took, the quiz we took today on proportions. It's just going to be for means. So make sure that you're studying the difference between those two and the different formulas and the different conditions that you need to check as well. But we're going to kind of take the idea of a confidence interval, and what we did today was we were trying to capture, right? And one of the questions that was asked before the quiz is the claim, and do we support the claim or do we not support the claim? And a confidence interval is one way to do that. If we're supporting the claim, then what is the confidence interval has to capture the claim. Is that correct? If the confidence interval captures it, then we can support it. If it doesn't capture it, then we can't support it. That's one way to do inference. The other is what's called a significance test, and we're going to test a claim, and there's a process by which we do that. Okay? So for today, our outcomes are, and I hope we have enough time to get through it all, we'll have to see, because 9.1 is where we've divided it into two parts. Today, I really only want you to figure out or understand how do we write hypotheses for a claim, and then how do we interpret p-values in context. And what is a p-value? And so we'll talk about what those things are today. The second half of 9.1 talks about errors. You have something called a type 1 versus a type 2 error, and we'll get to that next time I'm here, okay? So let's talk a little bit about what a significance test is, okay? So let's just kind of look at a scenario. So suppose we have a basketball player, go Tech, they beat UNC the other night. I was very excited. I think it was, what's today? Monday night. So let's suppose a basketball player claimed to be an 80% free throw shooter. That's pretty high. To test the claim, we have him attempt 53 throws. He makes 32 of them. His sample proportion of made shots is only 0.64. Okay? So what can we conclude about the claim based on that one sample? Well, right now, we would have to figure out a confidence interval. That's what we know based on our one sample. Would you agree? And we would find our significance level. We'd have to decide whether it's 95% or whatever. We would have to also, we have a sample. We have a p-hat. We could find a confidence interval to see if it captures. Okay? We could also use some software to simulate, kind of move my little guy here, to simulate 400 shots, okay? 400 sets of 50 shots, because that would be a sampling distribution of the same size, right? And we're going to assume, based on those, that he really is an 80% shooter. What would the sampling distribution look like? So if I had a software program that just did sample sizes of 50 over and over and over again, this distribution off to the right here, this graph that we see, might be something it looks like. It is normally distributed. It's got a unimodal and symmetric normal shape. We have a p-hat of 0.8 being our, a p of 0.8 being our center, correct? We could talk about what the standard deviation was, etc. So we can say how strong the evidence is against the player's claim by looking at the probability that he would make as few shots as 0.64. If you look at the distribution, there's only like 1 or 2 down here. Do you agree? Not many in the entire distribution would be true. So if he really is a free throw shooter of 0.8, and this happens, we could look at something called a p-value, and it's different than a p. A p-value is the probability. It's something different, okay? So we could look at the p-hat here. That doesn't look very likely. Do you agree? If he really is a shooter of 80%, is it very likely that he would have this kind of an outcome? Not really, okay? So that's kind of what we're looking at here. And that's called a p-value, and we'll talk about what that means in a minute. Any questions about just generally what we're talking about? All right. So, based on the evidence, we might conclude that he's incorrect because there's only one or two options, right? If we looked at our entire sampling distribution, there's only one or two scenarios where that could really happen. In reality, there are two. If you actually counted on the distribution, there were two. So we either have the player's claim is correct, and by bad luck, a very unlikely outcome occurred. That's one option. The other option is he lied, right? He boasted and said, oh, I'm 0.8. I have an 80% free throw shooting percentage. Liar, liar, pants on fire. And I had the stats to show it, okay? And so that's one of the things that you're trying to do here is prove people are lying to you, okay? So it's kind of fun. You can kind of say, well, I think you're wrong, and I'm going to do some math and show you why. So what we're trying to do in this basic idea here is an outcome that would rarely happen if a claim were true is good evidence that they're liars, okay? So if we have a rare event, does that make sense? Rare event that says that in this particular scenario, then we have evidence to say that they're wrong, which means that, and that probability is called a p-value, and if the probability is very, very small, that means the likelihood that this outcome happened, that means that we can prove that they're wrong. They're liars, okay? So we're going to do what's called reject the null. We'll get to what all that means in a minute. Okay so far? All right. So, hypotheses, okay? A lot of words here, but basically the middle part's what I want you to look at. Whenever you are doing a significance test, and there are lots of them that we will be doing, but just in general, the first thing you do is state the hypotheses. So we're going to come up with a list, kind of like a to-do list in terms of a structure of how to create a test. And there are 5 steps. The first step is to create the hypotheses, okay? And there are 2 of them. There is the null hypothesis, and there is the alternative hypothesis. In this case, in our example of our free throw shooters, and this is the notation that we would be looking at, I like to call them the ho and the ha, okay? H sub O stands for the null hypothesis. That's my ho. And my ha is my alternative hypothesis. That's H sub A. And that, in this case, is going to be the second one that I've listed, okay? Here's important information. The ho, right? The ho is always the claim. I remember this by thinking, oh, she claims to be a hoe. Okay? So I'm just saying, I know it's terrible. All right? But it's just kind of something that sticks in my head. All right? That's going to be the claim. The person claimed to be an 80% free throw shooter. Free throw shooter. I said that right? Free throw. Yeah, okay. Almost always it's an equal to scenario. Okay? It's the claim. It equals that thing. The alternative hypothesis is one of 3 options. It's either a greater than scenario, a less than scenario, or a not equals to scenario. Okay? We think the dude's lying. We think he's boasting because 80% is pretty high, right? So our alternative hypothesis that we're thinking that it's going to be less than 80. Okay, with what hypotheses mean. Okay so far? Now, what AP wants us to do is not only write it like this, but they want us to write it in words. So let's try to do that real quick. How would I write the null hypothesis in words? So let's kind of create like the words that would go along with this. What would I say? He claims he is an 80% free throw shooter. Is that okay? That's the claim. That's the null hypothesis. I want you to be able to write it in context, so in words, Also write it in the notation, okay? So you need to do both for me. How would I write the alternative hypotheses in words? The ha. Ha, 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 ha. We think, what? He claims he's 80%. We think that he's less than. Be careful, because don't say that he's not. Not 80% is a different situation. You have to describe, if you're testing what's called a one-tailed test in one direction, you have to be specific with your words. This means less than specifically. Okay? We think he shoots less than 80% of free throws. Good so far? Okay. So, again, here are the three scenarios. Your ha has three ways. Okay, three things. You can be greater than, you can be less than, and you can be not equal to. The key part here, and this is a very key part, is that always in your hypotheses, we're talking about the parameter, not the statistic, but the parameter. Because remember, think about your confidence interval. Your confidence interval is trying to capture a parameter, isn't it? So we're trying to make some conclusions about the parameter, about the population. That's the whole idea of inference, is being able to try to make claims or make judgments or make decisions about the population. Okay? So always your hypotheses will be written in terms of the parameter, which means we're writing it in terms of mu if it was means and p if it was proportions. Are we good so far? All right. Then we're looking at whatever the value is. Remember how I said that always in the null hypothesis, we're equal to, right? It's what the claim is. This is the claim. And then you have three options. This right here, when it's not equal to, is called a two-tailed test. When you have a two-tailed test, we're looking at literally two tails. It's not equal to what we think it is. He's either less than or he's greater than. Okay? All we can say is that it's not equal to. The two-tailed tests aren't as strong because you have more options to be in there, right? All right. So, hypotheses are always referred to a population parameters. It is never correct to write hypotheses about a sample statistic. I can't tell you how many times on either released exams that I've seen, practice exams, that this comes up. So it's often a multiple choice question, hint, hint, wink, wink, where you will see which are the correct null and alternative hypothesis for this situation, and they'll be written in terms of the statistic. Cross those out. You know they can't be right. Okay, either mu or p. Good? All right. So let's try to see if we can get through a little bit of an example about writing hypotheses and see what we would come up with. We might have to come back to our p-value in next class. So, does job satisfaction of assembly line workers differ when their work is machine-paced rather than self-paced? So we're asking a question. Here's our context. Here we have one study, and we've chosen 18 subjects at random from a company with over 200 workers. So let's figure out what this means. What information am I given here? What is the 18 versus the 200? $18 is the sample size, right? And 200 is the population, right? So are we looking at less than 10%? Okay, that's the condition. I just want you to kind of as you read through a problem, what information is being told to us. Half of the workers were assigned at random to each of two groups. Both groups did some similar assembly work, but one group was allowed to pace themselves, the other group was allowed to move at a fixed pace. After 2 weeks, all the workers took a test of job satisfaction. And then they switched workup setups and then tested again. The response variable is the difference in satisfaction scores. Okay, that's important. So my question becomes, what's the parameter of interest? What's the parameter? What are we trying to make claims about? Job satisfaction. Okay, let's see. Okay, it's the difference, right? Because we're talking about, in this scenario, there were two, right, of job satisfaction. So rather than just say job satisfaction, we have to think about the two different scenarios. We're looking at the difference here in this particular case. Okay, good. Next question, oops, I'm supposed to cover that up, sorry, would be to state the appropriate hypothesis for this particular case. What was the claim? What do you think? What would the claim be? Is there one that's given here? Is there a claim that's stated? 50%? Is there a 10%? Is there a claim that's stated? Not really, right? We have two scenarios. We're trying to figure out which one's better. Would you agree? Okay, so in this case, oops, I went too far. Because the initial question asked whether the job satisfaction differs, the alternative hypothesis is what's called two-sided. Is it different? It doesn't say is one better than the other. That's a two-tailed test. That's a not equal to scenario. Why do you think 0 is placed there?
There's no difference.
No difference would be that they have the job satisfaction is the same for both. So that would be there is no difference. That's a status quo. That's the claim. It doesn't matter. Then the alternative hypothesis would be there is a difference. We're not sure which one's better, but that there is a difference. Fair enough? Okay. Time-wise, we're kind of running out. I do want to kind of talk a little bit about what a p-value is, so you can attempt to do all of the problems from the homework. But really quickly, I kind of have alluded to it, but a p-value, again, I hate that they have the same letter, but it's different than p. Please know that. P is the parameter for the proportion. P-value is the likelihood or the probability that we're going to assume the claim is true, assume the null hypothesis is true. What's the probability that the statistic could happen? How likely is it that our outcome came about? Think about our free throw shooters, okay? The claim is 80%. The p-value is going to be very, 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 very small in our case because the likelihood that he shot is 62%, claiming that he's an 80% free throw shooter is very small. So a p-value is a probability. It's a likelihood. Small p, these are the important pieces, these are your important takeaways, these two check marks here. Small p-values are strong evidence against the null hypothesis, which means that our alternative has some truth to it, possibly. We're going to reject what we say that the null, their claim is wrong, and we have evidence to support the other. Large p-values don't give us any information against the claim. It may or may not be true, but we can't reject it. We can't say that the claim is false. For example, in our sample of basketball throwers, free throw shooters, if the sample we collected was like 73%, 74%, we probably aren't going to get a very small p-value. Think back to our picture here. Okay? In our picture, if I got about 75%, even though he claimed 80, 75% is about right here. Do you agree? Think about the proportion in your sampling distribution. It's not as small. Do you agree? So there's not a whole lot of evidence against the claim in that particular case. We're going to talk next class about how to find p-values. There are calculations, but so far all we have for our process are guys, I'm still talking. Thanks. For our 5-step hypothesis test or significance test process, we've covered step 1. All we've covered is hypotheses, right? The null and alternative, the ho and the ha. All right? Very good.